Okay, so for this one, yes, this one is going to require a little bit of some deep algebra skills. All right, let's have a look at this one. So of course, to find the arc length given the function, we need its derivative. So let's go ahead and find the derivative. But to find the derivative first, so let's rewrite this function as y equals to x, actually 1/6 x cubed plus 1/2 x to the negative 1, right? Be careful, it's not the whole thing that goes to the with negative exponent. It's only the x. All right, so let's take the derivative of this function. Y prime equals to, okay, so 3/6 x to the second minus 1/2 x to the negative 2, which is the same as saying 1/2 x squared minus 1/2x squared. All right, so that's the derivative of the function. And from here, we're going to set up the arc length for this one. All right. So let's recall the formula for the arc length. That's L equals the integral from a to b of the square root of 1 plus f prime, quantity squared, with respect x. And in this case, that's the integral from 1 to 2 of the square root of 1 plus that whole function 1/2 x squared minus 1/2x squared, the whole thing squared. All right, so in order to make this look like not a huge disaster, let's do some rewriting first. So I'm going to rewrite this integral the following way. So I'm going to write this as the integral from 1 to 2 times the square root of 1 plus x squared over 2. And I'm going to leave a space over here. You'll see why. You'll see why in a minute. Quantity squared dx. Okay? All right, the reason I left that space, it's because I would like to combine these two fractions together. And in order to get the fractions together, we need to find the least common denominator. In other words, we need to make sure that the two denominators are the same. In this case, they're not. But in this case, notice how the first term only needs an x squared, which is what I'm going to do here. I'm going to multiply both numerator and denominator by x squared to make that happen. Now, let's keep going over here. That's the integral from 1 to 2 of the square root of 1 plus big fraction 2x squared in the denominator, x to the 4th minus 1, the whole thing to the second power dx. All right, but again, in this case, by laws of exponents, notice that we have a quotient raised to the second power. That's equivalent to, say, the integral from 1 to 2 square root of 1 plus x to the 4th plus minus 1 squared over the square of 2x squared, which is 4x to the 4th power. All right, so this is what I'm going to do. So with respect x, let's square the binomial. So recall that last time I showed you a way to square a binomial. So rather than just foiling, which takes time, so why not just use the binomial expansion, the binomial formula. That's x squared, or rather, when we have, okay, x, well, not x, a plus or minus b, quantity squared, that's a squared, 2ab, and b squared. This is always positive, and plus minus depending on the case. So let's square the binomial that we have in the denominator of the second term inside of the radical. So let's see. So that's the integral from 1 to 2, the square root of 1. I'm going to leave a space. You'll see why again. So that's going to be, okay, the square of x to the 4th, which is x to the 8th. And in this case, minus 2 times the product between x to the 4th and 1, which in this case is negative 2x to the 4th, plus 1, the whole thing divided by 4x to the 4th with respect x. And while in the denominator of the first term, you can think of having an invisible 1 in here, and also have a, let's do a least common denominator again. All right, so I'm going to use this color. Oops, what happened here? Okay, so so in this case, the LCD, for the LCD we need to make sure but that both terms have a denominator of 4x to the 4th power. So let's go ahead and do that. Multiply numerator and denominator by x squared, 4x to the 4th, and divide by 4x to the 4th. Okay, so we may put this together into a single fraction. So that's the square root, so that's 4x to the 4th plus x to the 8th minus 2x to the 4th power plus 1, the whole thing divided by 4x to the 4th power. And then in this case, notice how we can combine like terms. So let's highlight those like terms. No, not blue, and yellow is fine. These two are like terms. All right, let's combine them together. 4x to the 4 minus 2x to the 4th. That's the integral from 1 to 2. Square root of, well, x, let's start with the highest power. 4 minus 2, that's a 2. Alright, so times dx. Okay, I don't need this. Alright, and let's see. Now let's look at the expression in the numerator of that radical expression, or the inside of the radical. Do you see the pattern? This is like the square 2 times the product of the first and the second. You know, like, okay, let's do some exercises here. Some like, oh, what happens? Why is that happening? Okay, so when you square, for example, x plus 2 squared. So that's x squared plus 2 times the product of the two terms, that is a 4x plus 4. And 3x minus 5 squared. Alright, that's 9x squared. 3 times 5, which is 15, but twice that's a 30. And minus 30x, and then plus 25. So that's the binomial square, but we're going to use the binomial square backwards in the same way that x to the 4th plus 1 squared. This is the same as x to the 8th plus 2 times x to the 4th plus 1, which matches this form, isn't it? But now we're going to use this backwards. So let me just box it. And So, and you will see how this integral will be a lot more simple. I know this one is taking a good minute to simplify, but we're almost there. X to the fourth plus 1 squared over 4x to the fourth power dx. All right. So far, so good. All right. So, well, the good thing is, guess what? Everything inside of the radical are perfect squares, aren't they? Okay. So in the numerator, okay, let me split it just so it's easier to see. So this is the integral from 1 to 2, the square root of x to the fourth plus 1 squared, and the square root of 4 x to the fourth with respect to x. This is really nice because cancel the radical with the power, and in the numerator we get the integral from 1 to 2 x to the fourth plus 1, and in the denominator the square root of 4, which is 2, and the square root of x to the fourth power, what is that? X to what power? X to the second. See how simple this integral is now? Well, in this case, let's how about you guys take this integral from here. I'm gonna give you a couple of minutes, of course. Talk to the person next to you, share ideas. If you get stuck, raise your hand. I will be more than glad to help you. All right. Maybe change the denominator sometimes. We'll figure it out. Looks good. Simplify this. Perfect. All right, let's have a look at this one. So, okay, so I guess the trick here is to split. Well, I'm gonna take, well, yeah, let me leave it like this, or you can take out the 1/2, and that's x to the 4 over x squared. That's an x squared, and 1 over x squared, that's the same as saying x to the -2, and from 1 to 2. So let's keep integrating these two terms. So the integral of x squared, which is x cubed over 3, and plus, or rather, well, minus in this case. All right, let me have the plus. X to the -1 over -1. So when you add 1 to the exponent, so we get that, and that evaluated from 1 to 2. So let me reduce the negatives, clean this up. Or rather minus 1 over x from 1 to 2. So that's 1/2. That's 2 cubed over 3 minus 1/2 minus 1 cubed over 3 minus 1 over 1. And let's do some arithmetics here to simplify this expression. So that's, let's leave the 1/2 for the end. So that's an 8 over 3 minus 1/2, and then minus 1/3, and then plus 1. Be careful here. I'm distributing that negative sign at the same time. And okay, let's simplify. 8/3 minus 1/3, is that 7/3? And then 1 minus 1/2, is that a 1/2? And combining these two fractions together, LCDs. So I need a 2, I need a 2, I need a 3, and I need a 3. So this is 1/2, so that's 14/6 plus 3/6, so that's 17 over 6 times 1/2, which is 17 over 12. All right? Yes. Let me zoom everything out. Let me zoom it out so you can see the whole thing. Maybe this far. Yes, guys. So as you can see from